So the activity that you were working on, if you got to it, about Lego prices was all about predicting the price of Legos based on some of the prices of some smaller sets. So as the sets get larger, we expect the price to go up. And then if we kind of see a trend and we look at the pattern, we can use that pattern then to extrapolate some information and make a prediction for larger sized sets of Legos. So what we're gonna do is, make sure that I'm on the right screen here. We are going to talk about scatterplots and how we use data to make predictions. And so that's why I really wanted you to try that activity first, is because sometimes we have a tendency to think with scatterplots that all we're doing is just graphing points and it doesn't really serve a purpose, but it does. What we're doing when we make scatterplots and graph them and draw the best fit line is we are creating a relationship between two values that will then allow us to make inferences about other values. So what I'd like to do is go through these notes, and then I'm going to show you how to perform linear regression on Desmos or on a graphing calculator, but we're going to do the Desmos option. So before we dive in, if you are sitting at a table that has a green like flag on it, you can take a mask break for a little bit, and then I will switch and we will do the people without the green tape and they can mask break. So first up, scatterplots allow us to show the relationship between two variables. And we typically are going to see, or not, I shouldn't say we typically, we're going to see one of three things happen when we look at variables graphed on a scatterplot. We will either see, I'd already saved all this, and now it's not going to, okay. So we will either see data that goes like this and forms what is called a positive correlation. So the data points are trending upwards, okay? The other option is we might see data where as one value increases, the other one decreases, and that would be like this. And I don't care where you put these points, you just want to see that negative trend, okay? So that's got a negative slope. And then the last one would be no correlation, which just means that we've kind of got dots all over. They're not going up, they're not going down, they're just kind of scattered in a scatter plot, which makes sense. Okay, so positive correlation, negative correlation, and no correlation. All right, so once we have our points from a set of data graphed onto a coordinate plane, we can look for that relationship and define it by drawing what is called a best fit line. So the best fit line is the line that gets as close as possible to as many of the points as we can. Okay, so we want to reduce the distance as much as we can between our line and the points that we have. So the first step is to actually draw our scatter plot. Now, on this scatter plot, we're going to graph the points that are telling us the depth of the water in a lake and the temperature of the water in the lake. So we've got depth and we've got temperature. So when we put this on a scatter plot, we need to assign our axes to these variables. We're going to put T as our independent or our dependent variable, and we're going to label this side of our scatter plot temperature, and it's measured in degrees Fahrenheit. Now, obviously, the lowest value is 76, the highest is 85, so we don't want to start at 0 and count by ones. We don't want to start at 0 at all, actually, because we're going to waste a whole lot of space, and our graph would be entirely positioned like way up at the top. So what we're going to do is put a break in the graph, and when you put a break in the graph, you just draw like a little zigzag down towards the bottom, like that, okay? And what that tells us is we're skipping a bunch of numbers, and then we can start plotting our numbers up here. I would suggest you put 70 at the line or two above your break, and then count by twos. So 2, 4, 6, 8, 80, 2, 4, 6, 8, 90. Okay? We don't need all that space, but this just gives us a good view of the data and that sort of thing. All right, and then across the bottom, we can fit it to go by ones, but I'm actually going to have you count by twos, and you can mark every one or you can mark every other. I'm just going to do every other. So like 2, 4, 6, 8, 10. And the reason why we're going to do that is because in a little bit, we're going to make a prediction about 25 feet. And if we counted every one, we wouldn't even be able to see that. This way, we'll kind of be able to gauge whether we are on track with our prediction or what our prediction, how the line shows our prediction. So just like we labeled the other axis, we're going to label this one. This is our D axis, and that stands for the depth of the lake, which is measured in feet. Okay, so now that we've got our labels and our scales, we need to plot our points. So our first point is going to be at 0 depth and 85 degrees. So right on that axis over here, we're going to go up halfway between 80 and 90 and put a dot there. That was a really big one. Okay, and then move over to 4 and go up to 82. 7 will be right in between the line before 8, so be sure that you account for that. That one's going to be right in the center of the box, and so on. So go ahead and plot the rest of those points. Once you've got your points, we are going to draw our best fit line. And so remember, I just said that our best fit line, it should be as close to the points as possible. So if I were going to do that up here, I'd want it to go kind of right through the middle of those points, kind of. It might touch 1 or 2 points. I feel like I'm complicated. That one's way too high. That first one, sorry, if you copied mine. Hopefully you did better than I did. There, that's better. Okay, so it should go right through the points and kind of keep them all centered around that line. So now here's the thing. Your best fit line doesn't have to touch any of the points. Like sometimes they could be positioned on either side and your line won't go through any of them, but it should kind of be in the middle of all of them. In this case, it does probably hit 1 or 2. In fact, I think the best positioning for this might kind of go through the first point and the last point. So let's draw our line there. And grab a ruler at a desk around you if you need to. We're going to connect the first dot and the last dot, and then make sure that you extend it even beyond. Oops. Okay, extend your line a little bit further than that last dot, because we expect that trend to continue. Okay, so now that we've got our line drawn, we want to figure out the equation of that line. And if we don't have technology, we're going to do that by hand. And we're just going to use the process that we learned yesterday when we were working on writing equations using a point and a slope. So I've got my line drawn. I can use these 2 points that are on the line to find the slope and then to write the equation. So those 2 points that we're using were 0, 85, and 15, 76. So our slope is going to be y minus y, so I'm going to go 85 minus 76 over x minus x, which would be 0 minus 15. And then just simplify, and you should get a slope of negative 3/5. All right, so now that we've got our slope, we can find the equation of our line. We're going to go y minus, and let's just use that first point there. So we're going to use this point. So we're going to go y minus 85 equals negative 3/5, and then x minus 0. And then if we were to do x minus 0, it would just be x. So we can simplify this. That would be negative 3/5 x. And if I move 85 to the other side, it would be plus 85. So our equation becomes y equals negative 3/5 x plus 85. So this is the equation of that line. Now, it's important to note that this line is not a guaranteed relationship. If I plug in a depth, I'm not for sure going to get that temperature if I go out and measure that depth and find the temperature. Okay, it's just a predictor. Okay, it helps us to get a good idea of what it might be, which is exactly what we're going to do next. We're going to predict what the temperature of the lake would be at 25 feet. Oh, we did this in the last class too. I'm sorry, we're going to go back and change our variables. So erase your y's and your x's. What should we use for the y value? T, because we're predicting the temp. And then the input variable, we should be using D for depth. That'll make it much easier to use our equations, okay? So if we want to predict the temperature of the lake at 25 feet, 25 feet is our depth. So we're just going to plug into that equation and find what T minus or equals negative 3/5 times 25 plus 85 gives us as a value for T. So if you multiply in your calculators or you cancel out your 5 and your 25, you get negative 15 plus 85, which means our temperature is expected to be 70. And that's exactly what this is called. It's called an expected value. So we're going to say at a depth of 25 feet, we expect a temperature of 70 degrees Fahrenheit. Okay, we're not saying it's for sure going to be 70. We're just saying that's a good guess as to what we might find. All right, now this next part is going to be a little bit different than what they have on your notes because we are not going to use your graphing calculator. We are going to use Desmos. So I'm going to leave this sitting here and I want you to make some changes to your notes so that you can refer back to this. I'm going to open up Desmos, and you're not going to be going to this Desmos, not this activity, but rather you're going to go to desmos.com. and you're going to click on the graphing calculator. So once you are at Desmos, I'm going to try to slide this up so you can see both my screen for your notes and your activity. So once you're at Desmos, our steps are as follows. So I'm going to cross off calculator steps because they're not for our calculator, they are for Desmos. And once you're into your graphing calculator, you're going to click the little plus button. So instead of hit stat enter, you're going to hit the plus button, and then you're going to choose to enter or to choose to insert a table. So the little plus button up in the corner of your screen up here, hit plus, choose table, and then you get a table that you can start entering your values into. We are going to enter the values that we're going to use into our columns, which are labeled y sub 1 and x sub 1. And we're going to use the same label or the same numbers that we just did to see how good our best fit line really was. So we're going to go 0, 4, 7, 10, 12, 15. And then on the other side, we're going to do 85, 82, 81, 79, 77, 76. And what you'll notice is that you can't really see those points because of the size of our graph and how zoomed in it is. So if you want to reposition your graph, you can click and drag, but it's much easier if you just click this little button in the corner with the magnifying glass and the plus. It's going to reposition and resize your graph so that we can see those points. Okay, so that's going to look just like what we had on our papers, except they're green. And now we need to find our best fit line. Okay, and this is going to be like literally the best fit line. It's going to be the line that minimizes the distance between the line and all of those points. So to do that, you are going to click right underneath your table, right here after your 2. Okay, so you're going to click right down here, and you're going to type the equation. Okay, let me find my spot. Okay, so then you're going to, in number 2 spot, you're going to type the equation y sub 1 and then a little like tilde m x sub 1 plus b. Okay, now the little sub 1 naturally goes small under your y if you just type a 1. So really you're just typing y1, and then the tilde is the shift and the button right up by your 1 key. mx1, which happens automatically, plus b. And it will automatically draw your best fit line for you and give you all the values that you need to write that equation. So based on what we just did, the m down here and the b down here are the m and the b for our best fit line. So from the calculator, so basically none of this, or we're not going to use any of that. From the calculator, or from Desmos, we get y equals negative point, is it like 60? I can't read it up here very good. 60666667.
Yeah.
Yeah. So let's just do like negative 0.61. We're gonna round to the second decimal place for now. X plus 84.85. Okay, what's negative? Let's look back up at our equation that we had. On when we did it by hand, we got negative 3/5 at D plus 85. What's negative 3/5 as a decimal? 0.6, which is pretty darn close to what we got. And then we had plus 85, and this gives us plus 84.85. So it's also pretty close, right? So this is how you do it via Desmos, okay? It's pretty simple. What I would like you to do for Monday is just the back side of this worksheet. There are 4 problems. All you have to do is type those into a table, get your, it's called the line of regression, and then make a prediction. And I'm going to show you real quick how to make the prediction part even easier than plugging it in and working the equation out on your own. Like on this one with the depth and the temperature, we predicted the depth at 25, right? All I need to do is type my equation with my 25 plugged in. So we would go y equals, and then my m that it gives me right there, so negative 0.61 is what we're going to estimate it to be, times 25 plus 84.85. And this tells us that the predicted temperature using this least squares regression line that we just found via Desmos is 69.6. We got 70 when we did it all by hand. Both very similar. We're good to go. Make sense? All right. If you forget the steps, this video will be on Canvas.